Okay, so this is going to be support for the homework that you were given earlier today. So graphing these inequalities, the primary thing is just making sure that we're shading and coming up with the correct solution set for each one of them. So let's just go ahead and go over these one by one. Number one, we're going to go ahead and graph each one of the inequalities separately. So for number one, we're looking for the y-intercept first, which is going to be 2. My slope is 1 over 3, so I go up 1 over 3. Because this right here is strict, we are going to end up having a dotted line. And because it is less than, we are going to shade below. Alright, for the next one, we'll go ahead and change colors here. Start at the y-intercept, which is -3. My slope is 2 over 1, so we go up 2 over 1. Again, we're dealing with a strict inequality, so it's going to be a dotted line. And because it is greater than, we are shading above. So we can clearly tell where these two areas overlap. They're going to overlap in this area. So we're going to indicate clearly what our solution set is for this system of linear inequalities. Number two, same thing, graph it. Start first with the y-intercept for the first one, -1. My slope is -1 over 3, so I'm going to go down 1 and to the right 3. Because this is not strict, it's going to be a solid line. And because it is greater than, we are going to shade above this area. All right, for the next one, our y-intercept is, I'm going to change colors, -3. My slope is positive 1/3, so we're going to go up 1 over 3. This is going to be strict because it's not equal to, so we have a dotted line here. And we're being told that this is less than, so we're shading below. So my area of overlap is going to be my solution set, which is right there. Okay. Number 3. Now again, this is a big catch for a lot of people because we don't understand what this graph looks like right here. However, x is less than or equal to -3. Well, if I replaced this with just x equals 3, x equals -3, x equals -3 is a horizontal line that runs through x equals -3. Well, the inequality is now x is less than or equal to -3, so it's still a vertical line and it's solid because it's not strict. And because it is less than, we are shading to the left of this line. For my next one, my y-intercept here is +1, so this is where I start from. My slope is -2 over 3, so I go down 2 over 3. It's a strict inequality, so we have a dotted line. And because it is greater than, we shade above this line. Now we can see again, it's very important that we have good straight lines and clear areas because in this case we have a very small portion right here at the top where we have an overlap, and this is my solution set for that inequality, or for that system of inequalities. Next one's a little bit easier. We start off with our y-intercept, +2. Now this is our slope -5, so we go down 5, 1, 2, 3, 4, 5, and then we're going to go over 1. It is strict, so we're going to do a dotted line. Now, we are less than for our inequality. Well, I may not necessarily know which side do I want to be on, over here or over here. I'm not really sure which is above or below. If I don't know, let's go ahead and pick a test point. If the test point proves true, then we shade in that direction. The most famous test point is always 0, 0. So we take this inequality, y is less than negative 5x plus 2. We'll plug the point 0, 0 in. So we have 0 is less than negative 5 times 0 plus 2. So we have 0 is less than 2, and that is true. So then we know wherever that point is that shows true, that is the direction in which we are going to shade this line. Okay, let's try the next one. Next one, our y-intercept is negative 2. Our slope is negative 1, so we're going down 1 over 1. We have a dotted line because it is also strict. And because it is less than, we are shading below. Okay? Now, we have to kind of think to ourselves, okay, now where is the common area where these are going to be shaded together? And we can see that my common area here, since the purple goes this way right here, and the red goes this way right here, I start to create an upper bound, which is this area right here, and this area right here. Anything below is where I will have both the red and the blue, or the red and the purple, both overlapping. So that's my solution set for number 4. All right, number 5. The best way to go ahead and do this is to place both of them in slope-intercept form. So we rewrite the first one. We have x minus 2y is less than 4. I'm going to subtract the x from both sides. So we have negative 2y is less than negative x plus 4. Divide the negative 2 by all 3 terms. And so we have y is greater than, because we change it since we divided by a negative. The negative divided by a negative is positive, so we have 1 over 2x. 4 divided by negative 2 is negative 2. When we rewrite this one right here, this is a little bit easier. We subtract the x from both sides, and so we're left with y is greater than negative x plus 1. So let's do this first one right here. Y is greater than negative x plus 1. Start at the y-intercept. My slope is negative 1, so it's down 1 over 1. It's strict, so it's a dotted line. And then we have a greater than, so we're shading above this line right here. All right, now we'll go ahead and graph this inequality. We start at negative 2 for our y-intercept. Our slope is 1 over 2, so we're up 1 over 2. A dotted line because it is strict. And it is greater than, so we're shading above this area right here. Okay? So we can start to see where that solution set is going to end up being. This is the upper bound, or the lower bound for it right here. And it's everything above. Any ordered pair in this solution set right here will satisfy both inequalities. Okay, we'll go ahead and do one more, and that should be sufficient to go ahead and take you the rest of the way through the homework. The next one here, put this in slope-intercept form. We're going to subtract the x from both sides, so we get y is greater than or equal to negative x plus 1. Same thing here, we'll rewrite this equation. Subtract the x from both sides, so we're left with negative 2y is greater than or equal to negative x plus 4. Divide the negative 2. That means if we're dividing by the negative 2, we are also changing the inequality. So we have y is less than or equal to 1 over 2x minus 2. Let's go ahead and graph the first one here. Our y-intercept is positive 1. My slope is negative 1, so I'm down 1 over 1. It's not strict, so I have a solid line. And because it's greater than, we're shading above. The next one, we have a y-intercept of negative 2. I have a slope of 1 over 2, so I'm up 1 over 2. This is not strict as well, so we have a solid line. And this is less than. So we can start to see again where that solution set is. This is the upper bound of it right here. This is the lower bound. It's everything in the middle.